wall shooter. It drives a nail into concrete without drilling, by firing it out of a gun barrel at nearly 1,300 feet per second. That's a 9mm handgun. Out of a tool you can rent. The powder-actuated tool built in the Second World War to shoot patch plates onto torpedoed hulls. Inside is a blank cartridge. Pull the trigger and the gas pushes straight on the nail's head. The nail is the bullet. Nothing in the tool limits how far it goes. Hit a void and the nail keeps almost everything the powder gave it. From the accident report, a man fired into a hollow wall. The nail went through, flew 27 feet and killed a 22-year-old apprentice. The fix is one part, a heavy steel piston. The gas never touches the nail. It drives the piston down a short stroke and the piston punches the nail like a hammer. Then the piston bottoms out on a shoulder in the barrel, and the pushing is over. Miss the concrete and the nail still carries only that one hammer blow. 300 feet per second is now the standard's definition of the safe kind. Nobody in America has sold the other kind since the 80s. It never had a safety problem. It had a ballistics problem, the monster. Stanley sold it as 55 planes in one box. It was bad at all 55. The Stanley number 55 1897. Marketed, and I quote, as a planing mill within itself. A wooden molding plane works because its sole is the exact reverse of the shape it cuts. The blade beds in that sole supported to its edge. The sole holds the wood down ahead of the cut. The 55 has no sole. The cutter is pinched between two thin steel skates, the rest of it in midair. 7 adjustments, every one a chance to be wrong. And no mouth. Nothing holds the fibers down ahead of the blade. The grain lifts and tears out. Patrick Leach, the reference on Stanley tools, calls it a temperamental monster. Stanley kept selling it until 1962. What buried it was the electric router, a cutter in a base that touches the wood everywhere the 55 doesn't. The cutters were never the problem. The support was, Stanley sold a planing mill in a box and forgot the mill. The liar. It was invented to stop mine explosions. Its actual effect was to multiply the dead. The Davy lamp, Humphrey Davy, 1815. The problem is fire damp. Methane seeps from the coal, and the miner needs a flame to see by. Davy's answer, a cylinder of fine iron gauze. The gas isn't kept out. Methane goes through the mesh into the lamp and burns in there. The flame can't get out. The gauze is a heat sink. It pulls heat from the burning gas faster than the flame can cross the holes, so the flame dies at the mesh. Quenching only works if the gas is slow. Put that lamp in a draft of 4 to 6 feet per second, a brisk walk, and the flame goes straight through. Trimden Grange, 1882. A roof falls in, the collapse shoves a blast of air through a Davy lamp, and the flame passes into a pit of methane. Nearly 70 men dead. The lamp worked well enough that owners could work seams that were unworkable. Deeper. Gassier. Deaths went up. Davy handed the industry a safety margin. The industry spent it. The drunk? Somebody looked at a spinning saw blade and thought, what if it were crooked? The wobble dado, really the drunken saw. The job. A groove wider than your blade. The proper way is a stacked dado, flat disc sandwiched as wide as the groove. One blade and a con, clamped between tapered washers, you twist against each other, tilting it off square. A tilted disc doesn't sweep a plane. Every tooth sits the same distance from the center, so as it spins it sweeps a sphere, deepest in the middle of the groove, shallowest at the walls. The floor comes out dished. It cuts a flat bottom at exactly one setting on that dial. It won't be the one you need. Then the shaking. A tilted blade isn't unbalanced in the normal way. The weight is still even around the shaft. It's a dinner plate bolted to its axle a few degrees out of square, spun about its own center, but crooked, fighting to twist itself upright, once a turn against your arbor. Lead on the rim can't cancel that. It isn't a pull. It's a twist. And the harder you tilt it, the harder it fights. So the vibration gets worse the wider you set the cut. The dial that sets your groove and the dial that beats your arbor bearings to death are the same dial. The stacked set 1. The drunken saw is extinct in any shop that cares, and in Britain you can't even fit one. The arm. 18,000 parts built to imitate a human hand, and it ruined Mark Twain. The Page compositor. James Page worked on it for 17 years. A compositor picked lead letters from a case by hand, one at a time. After printing, somebody put every letter back in its compartment. That job has a name: distribution. The distributor is the masterpiece. It reads the notches cut into each letter's side and drops it into the right channel. It reads type by touch. 18,000 parts at watchmaker tolerances, 18,000 chances to be out of spec. Fewer than 6 were ever finished. Mark Twain sank $300,000 in. While Page perfected his machine, Mergenthaler shipped the linotype, which doesn't pick up letters at all. It casts a fresh line of type from molten metal, prints with it, then melts it down. Nobody puts the letters back. So the masterpiece, the mechanical hand that reads type by touch, was now a beautiful solution to a job that had stopped existing. 17 years, and the problem got up and left. It ran 60 days at the Chicago Herald. Twain lost the money. Page died in a poorhouse. The puller. 3.7 million recalled, and for a lot of them, the only fix on offer was mailing the cutting half of the machine back. The radial arm saw. Raymond DeWalt, 1925. Motor and blade hang from a carriage rolling freely along an arm. You pull it through the cut. Where the teeth meet the wood, they travel down and backwards into the fence. That's what pins the board tight to the fence, so you never clamp it. Every action has an equal and opposite one. The teeth shove the wood into the fence, so the wood shoves the blade forward along the arm, toward you, and the carriage is free to roll that way. It feeds a little, takes a bigger bite. A bigger bite is a bigger shove, so it feeds faster still. It winds itself up and climbs the wood at you. Faster, the more it does it. 2001, the Craftsman recall, after 300 injury reports, including amputations, sold without a guard that covered the whole blade, a guard that existed as an optional extra. Emerson offered a free retrofit guard, and for the saws too old to take one, $100 to mail back the carriage, the cutting half of the machine. What replaced it is the miter saw. Still one way to move, but it's a hinge. Captive on an arc, it cannot leave. One less degree of freedom, and the saw can't run away from you. The sundial. A compass that ignores magnetism completely, because the ground was lying. 1835. William Austin Burt is surveying the iron country of Michigan, and his compass needle is wrong. Not broken. Wrong. There's so much iron ore underfoot, it drags the needle off true. So he takes the magnet out of the answer. Burt's solar compass finds true north from the sun. 3 brass arcs, an analog computer. Set the first to your latitude that tips the assembly so one axis of the instrument is parallel to the axis the Earth spins on. Set the second to how far north or south of the equator the sun is today. You read that off a table in your pocket. The third, to the time of day. Then you turn the instrument until the sun, through a lens, drops its image onto the target lines. When that spot lands in the middle, the sights point at true north. 3 brass hinges have solved spherical trigonometry, and the ore under your boots is irrelevant. So why isn't every surveyor carrying one? No sun, no north. Useless under cloud, at night, in timber. Everything that replaced it carried its own reference. A survey network, eventually a satellite. He fixed a compass that lied by refusing to ask it anything. Which works, right up until it's cloudy. The Woodpecker. It spent a third of its working life traveling backwards and died when somebody did the arithmetic. The Metal Shaper. Nasmyth, 1836. For a century, this is how you made a flat surface. One hardened cutter on a heavy ram punching back and forth. The quick return linkage, a pin on a big gear rides in a slot in a link, sweeping more than half a circle going out and less than half coming back. Slow, powerful stroke out. Fast, lazy return. Then the clapper box. On the cutting stroke, the cut slams the tool holder shut against its stop. On the return, the tool would scrape backwards over the surface it just cut, so the holder swings up, rides over the work, and flops down. A hinge that apologizes for going backwards. The shaper cuts with one edge and only on the way out. A milling cutter has a dozen teeth, several of them in the metal at any instant, and it never stops cutting. So why did it live 100 years? A shaper's cutter is a lump of tool steel you grind yourself on a bench grinder. A mill's is a cutter you buy. It won on tooling cost. Then mills got cheap. Machine time got cheaper than a machinist's afternoon, and the thing it was winning on evaporated. No scandal. No amputations. It just got outmade. The chimney turbine? A gas turbine in your fireplace, cooking your dinner. For free. The smoke jack, English kitchens ran them from the 1600s. The job, turning the roasting spit, otherwise a boy, a servant, or, this is real, a small dog in a wheel. It replaces the dog with a turbine, up in the chimney, a horizontal wheel with vanes angled to the flow. The hot exhaust rises, hits the vanes, spins it. Then it gears down to a chain running down to the spit. Efficiency killed it. The turbine is a parasite. It doesn't live on heat. It lives on the river of room air. An open hearth hauls up an open chimney. Count Rumford's project from the 1790s was to narrow the throat and close in the fire. Then the closed iron range swept British kitchens. A closed range still sends gas up a flue. It has to, or it wouldn't burn. But it's a trickle up a pipe instead of a river up a chimney. The working fluid wasn't killed. It was throttled to nothing. And the roasting moved inside the oven. So the spit it turned went too. Its working fluid was engineered out of existence by people correctly trying to stop wasting heat. The first domestic waste heat turbine, killed by the invention of not wasting heat. 9 tools that were all at some point somebody's best idea. If you enjoyed watching them fail, there's a whole video of engines that did the same thing on screen now. Send it to the Scrapyard.